your calculus class, it's just an algebra class. As you progress through the material of the course from limits to derivatives to integrals, what you'll notice through all the problems is that you heavily rely on your algebra. I'm talking about things like factoring, foiling, and exponent rules. So we're going to work through a couple practice problems that you'll see throughout the course, and we're going to focus on the algebra. Here's a common limit problem, and what we'll notice is we're going to want to factor the numerator. Note that 3 only has factors 1 and 3, so we're going to have to put a 3x and an x. That same logic applies here and here, where 3 has only factors 1 and 3. And then to produce the negative 8, we need to have a negative 9 and then a positive 1. Now what you see is that these factors x minus 3 and x minus 3 cancel out in the numerator and the denominator. And so we're just left with the limit of 3x plus 1. And with direct substitution, we just plug in the 3 and we get 10 as our final answer. Note that without factoring, we would have never been able to solve that problem. We're also going to need to know how to FOIL. So in this example, what we notice is that we can't solve the limit right away as is. But when we FOIL this term, which might help us to rewrite this as those two terms multiplied, it comes out to 25 minus 10h plus h squared. Here, the 25 and the negative 25 cancel out. That simplifies the limit as h goes to 0 of h squared minus 10h over h. We'll also notice that here you can pull out an h from the numerator. We'll factor that out. We'll cancel the h's, and we're left with the limit as h goes to 0 of just h minus 10. Plugging in 0 using direct substitution, we get an answer of negative 10. Again, notice the importance of our algebra. Now, we also shouldn't forget our exponent rules. In this example, we're given the function f of x equals the cube root of x, and we're trying to find its derivative. What we'll first do is rewrite the cube root of x as x to the power of 1/3. Note that the index of a root becomes the denominator in our fractional exponent. Now we take the derivative. Then we just do a rewrite where we bring the negative exponent to the denominator, making it positive. Then we rewrite x to the power of 2/3 as the cube root of x squared. Remember, the denominator of the fractional exponent becomes the index of our root. Now let's say that we wanted to find f prime of negative 8. What we'll notice is that when we plug in the negative 8, we'll actually want to take the cube root of negative 8 first. That will produce a smaller number, and then we can square the result after. This is allowed with exponent rules, so the two can kind of interchange back and forth inside and outside the square root. We wrap up by taking the cube root of negative 8, which is negative 2, squaring it to get 4. 3 times 4 would be 12. 1 over 12 is our answer. So after doing all those problems, now you know what I mean when I say